Yes, ceiling fans can be used on arc fault circuit interrupter or AFCI circuits without causing any problems, provided that the circuit is properly sized and installed. The National Electrical Code, or NEC 2020, requires AFCIs on all 120 volt, 15 and 20 amp branch circuits supplying outlets and permanently installed fixtures in bedrooms. This includes both outlets and lighting circuits. Ceiling fans typically require a 15 amp circuit. The AFCI device must be rated for the circuit amperage. AFCI should be installed in a panel board or weatherproof enclosure. The circuit wiring should be properly sized and connected to the AFCI device. If ceiling fans are causing AFCI tripping, it could be due to several reasons. Firstly, loose connections. Check all wire connections at the fan, AFCI device, and panel board. Secondly, an overloaded circuit. Make sure the fan is the only load in the circuit. Thirdly, fan speed control. Some fan speed controls may cause nuisance tripping. Try using a different type of control or connecting the fan directly to the circuit. Fourthly, a defective fan. A faulty fan motor or capacitor can cause AFCI tripping. Using ceiling fans on non-AFCI circuits is not permitted in areas where AFCIs are required by code. This includes bedrooms in most jurisdictions. To ensure safety and compliance with code, it is recommended to use ceiling fans on properly sized and installed AFCI circuits. If tripping problems are encountered, it is important to troubleshoot and resolve the issue before operating the fan. AFCIs, or arc fault circuit interrupters, are designed to protect against electrical fires caused by arcing faults. An arcing fault is an unintentional electrical discharge between two or more conductors. These faults can occur due to damaged wiring, loose connections, or faulty appliances. AFCIs detect these arcing faults and quickly shut off the power to the circuit, preventing a fire from starting. There are two main types of AFCIs: firstly, branch/feeder AFCIs, and secondly, outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the panel board and protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet on the circuit and protect the wiring downstream from that point. The NEC requires AFCIs in several locations throughout the home, including bedrooms, living rooms, dining rooms, family rooms, hallways, and closets. The specific requirements vary depending on the addition of the NEC and local amendments. When installing a ceiling fan on an AFCI protected circuit, it is important to follow a few key steps. Firstly, ensure the circuit is properly sized. Ceiling fans typically require a 15 amp circuit. Check the fan's specifications to determine its amperage requirements. Secondly, use the correct type of wiring. The wiring should be properly sized for the circuit amperage and be in good condition. Damaged or undersized wiring can cause arcing faults and lead to AFCI tripping. Thirdly, make secure connections. Loose wire connections are a common cause of arcing faults. Ensure all wire connections at the fan, AFCI device, and panel board are tight and properly made. Fourthly, consider the fan speed control. Some fan speed controls can cause nuisance tripping of AFCIs. If you experience tripping problems, try using a different type of control or connecting the fan directly to the circuit without a speed control. Fifthly, test the AFCI. After installing the fan, test the AFCI device to ensure it is working properly. Most AFCIs have a test button that will simulate an arcing fault and cause the device to trip. If the AFCI does not trip when the test button is pressed, it may be defective and need to be replaced. If you are experiencing nuisance tripping of an AFCI with a ceiling fan, there are several troubleshooting steps you can take. Firstly, check for loose connections. As mentioned earlier, loose connections are a common cause of arcing faults. Check all wire connections at the fan, AFCI device, and panel board. Secondly, reduce the load on the circuit. Make sure the fan is the only load in the circuit. Other appliances or devices on the same circuit can overload the circuit and cause the AFCI to trip. Thirdly, try a different fan speed control. As mentioned earlier, some fan speed controls can cause nuisance tripping. Try using a different type of control or connecting the fan directly to the circuit without a speed control. Fourthly, inspect the fan for defects. A faulty fan motor or capacitor can cause AFCI tripping. Inspect the fan for any signs of damage or wear. If you suspect the fan is defective, have it repaired or replaced. Fifthly, consider the age of the AFCI. AFCIs can become more sensitive over time and may be more prone to nuisance stripping. If the AFCI is several years old, it may be time to replace it. Sixthly, consult with a qualified electrician. If you have tried all of these troubleshooting steps and are still experiencing AFCI tripping problems, it is best to consult with a qualified electrician. An electrician can properly diagnose the problem and recommend the best solution. In some cases, it may be necessary to replace the AFCI with a different type of device, such as an arc fault current interrupter, or GFCI, or ground fault circuit interrupter. GFCIs protect against ground faults, which are different from arcing faults. A ground fault is an unintentional electrical discharge between a conductor and ground. GFCIs detect these ground faults and quickly shut off the power to the circuit, preventing electrical shock. While GFCIs do not protect against arcing faults, they can be used in conjunction with AFCIs to provide comprehensive electrical safety. It is important to note that local electrical codes may vary. Always check with your local building department or a qualified electrician to ensure you are complying with all applicable codes and regulations. Using the correct type of wiring is crucial for ensuring the safe and reliable operation of electrical circuits. The NEC specifies different types of wiring for different applications. For example, non-metallic sheath cable, or NM cable, is commonly used for residential wiring. NM cable consists of two or more insulated conductors wrapped in a plastic jacket. The size of the wiring is also important. The wiring must be sized to handle the amperage of the circuit. Undersized wiring can overheat and cause a fire. The NEC provides tables that specify the appropriate wire size for different amperage ratings. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical outlets and appliances should be properly grounded. Grounding can be achieved by connecting the grounding wire to a metal water pipe or a grounding rod. Electrical safety is paramount. Always follow safe work practices when working with electricity. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools. Thirdly, never work on electrical circuits in wet conditions. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician. In addition to AFCIs and GFCIs, there are other safety devices that can be used to protect against electrical hazards. Firstly, surge protectors protect against voltage spikes that can damage electronic equipment. Secondly, smoke detectors provide early warning of a fire. Thirdly, carbon monoxide detectors provide early warning of carbon monoxide poisoning. By taking these safety precautions, you can help protect yourself and your family from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or troubleshooting. A qualified electrician has the knowledge, skills, and experience to safely and effectively handle electrical tasks. They can also ensure that your electrical system complies with all applicable codes and regulations. Maintaining your electrical system is also important for ensuring its safe and reliable operation. Regularly inspect your electrical system for any signs of damage or wear. Replace any damaged or worn components immediately. Also, have your electrical system inspected by a qualified electrician every few years. An electrician can identify potential problems and recommend preventative maintenance measures. By properly maintaining your electrical system, you can help prevent electrical fires, shocks, and other hazards. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Local jurisdictions may adopt the NEC with or without amendments. It is important to check with your local building department to determine which edition of the NEC is in effect and any local amendments that apply. The NEC is a valuable resource for electricians, contractors, and homeowners. It provides detailed information on how to safely and effectively install and maintain electrical systems. The NEC is available for purchase from the National Fire Protection Association, or NFPA. Understanding the basics of electricity is also helpful for homeowners. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Amperage is the rate of flow of electrons. Resistance is the opposition to the flow of electrons. These concepts are related by Ohm's law, which states that voltage equals current times resistance, expressed as volts equals amps times ohms. Electricity can be dangerous if not handled properly. Always follow safe work practices when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician. Electrical codes and standards are constantly evolving to improve safety and performance. Staying up to date on the latest codes and standards is important for electricians, contractors, and homeowners. The NFPA offers a variety of training and certification programs for electricians and other electrical professionals. These programs can help you stay up to date on the latest codes and standards and improve your skills and knowledge. Investing in electrical safety is a wise decision. By taking the necessary precautions, you can help protect yourself, your family, and your property from electrical hazards. Remember to always prioritize safety when working with electricity. If you have any questions or concerns about electrical safety, consult with a qualified electrician. They can provide you with the information and guidance you need to make informed decisions about your electrical system. Electrical safety is a shared responsibility. By working together, we can help create a safer environment for everyone. Remember, electricity is a powerful force that should be treated with respect. By following safe work practices and staying informed about electrical codes and standards, you can help prevent electrical accidents and ensure the safety of yourself and others.